The purpose of this video tutorial is to show how to validate crack deflection when given an amount of base reinforcing in Adapt Floor Pro 2010. So in this condition we have 4 slabs. Each of the slabs has the same geometry and same loading input. The only variable for each of the slabs is the number 5 bars in the slab. The far left slab has the more dense spacing of bars. Moving left to right, we get less dense on the right hand side. So here we have 5 number 5s, 15 number 5s, 30 number 5s, and 50 number 5s. It's also important, if we review the load combinations, we have one load combination which is service load. We've set the analysis design option to crack deflection, so we only have the single combination to make this check. If we have additional combinations that are set to service or strength condition, the program will add reinforcing if those two conditions are not met by the base rebar. So if you're trying to validate what happens when you increase the quantity of base reinforcing in a slab with respect to the crack deflection, the results may not differ because the program would be adding rebar just to satisfy strength and service demands. So in order to make the check, we recommend only setting up load combinations set to crack deflection. We'll go ahead and we'll mesh this particular structure, or these 4 slabs, and then we'll analyze the structure. Once the analysis is complete, we can go to the FEM tab, go to View Analysis Results, and we're just going to check the uncracked deflection for the service condition, and we can see that the uncracked deflection is the same for each of the slabs. So we now need to generate the design sections. Even though no reinforcement is going to be designed, we have to generate and design the sections in order for the base reinforcement to be initialized for the cracked deflection calculation. So we've set up our design strips in the X and the Y directions, and going back to FEM, we're going to design the design sections for those strips, and we can validate that no rebar is being designed for any other load combination or for the combination we've input by going to FEM, generate rebar drawing. For the envelope, we can select OK, and we can see no rebar is required. So we'll cancel out of that, and now we can go back to FEM and calculate the crack deflection based solely on the I cracked given from the reinforcement that we've input as base rebar. We'll go back to the View Analysis Results, and we want to check the loading or the deflection for cracked service total load, and we can see moving left to right that the crack deflection increases from around 2.99 inches on the far right, and then the far left it's only around 2 inches. So it's increasing left to right where we have very little base reinforcing here. We can also go to the slab actions and go to the reduced rotational stiffness about the y-axis, and this will show us the extent of cracking between the different slabs. So we can see we're getting more reduction in stiffness moving left to right, where here it's essentially 0, and at the far left it's around 0.25. This will conclude the video tutorial on how to validate cracking results in Adapt Floor Pro 2010.